Okay, hello. Good afternoon, everyone. I'm Kashyap. A quick shout out to my co-authors, Camille, Gilles, and Antti Oulasvirta. This work was done last summer when Camille was visiting our lab in Aalto University as a summer intern. And I'll be talking about SAM, which is self-adapting web menus. This morning, we heard the award talk on Supple where we heard a lot about adaptive user interfaces and their promise. But then we also heard about difficulties in actually realizing that dream in the real world, and how we finally had only achieved these toy successes such as responsive design. And in my talk, I'll try to address this issue about real world adaptive. Sorry about that. Okay, sorry. Yeah, about real world adaptability and how SAM aims to achieve that. So we're going to be talking about menus, which are pretty much everywhere we go on the web. They render themselves in different forms and fashion, for example, sidebars or top menus, hierarchical menus, and all different ways. And they let us basically achieve quite important tasks such as navigation or tool selection. And so obviously the line of research into menus is quite long. It goes from design of menus and optimization techniques to interaction with menus, different types of visualizations, how you can show menus to the users, and finally also adaptive menus. So this is quite an important line of research for the HCI and IUI communities. But research efforts are often quite isolated and fragmented. They exist on their own and don't end up being integrated really. And the prototypes are often not deployed or adopted, as I mentioned earlier. And finally, replication becomes challenging because each research area has their own form of implementation. And these are some questions we try to answer with our research here. So how can we make the web fully adaptive? Of course, there are many concerns when we try to do that, such as there's the issue with disparity in designs where different web pages render menus differently, compatibility between browsers, privacy and security issues while trying to collect user data. And these all make it challenging for us to adapt websites fully. And so how SAM aims to do that? First, a quick example on self-adapting menus with SAM. So basically, on the left side, you have a static menu, and on the right side, you have a fully adaptive menu where you have different adaptations such as the moving of elements, highlighting of elements, gradual highlighting. These were discussed also earlier today on the design space of adaptive interfaces. And these are different things that can be achieved with SAM. How does SAM do it? Basically, SAM decomposes adaptive menu into two main components. One is a target policy, and the second we call the adaptation style. What the target policy does is basically it computes importance of different items in the menu to say which ones are more important and which ones need to be adapted. And in the next stage, we can apply different styles of adaptations which specify the visual changes that we need to make to the menu to adapt it for each user. And by combining these two aspects and making them modular in nature, we can finally have a fully modular approach for self-adapting menus on the web. And here you could mix and match different combinations, and it also facilitates extending these aspects individually. I'll go into the details of these a bit later, but first I'll show you the SAM framework itself and how it works. So again, on the left-hand side, you'll see a static menu, the original menu. And in the first step, what happens is you take the DOM from the HTML of the menu, and you abstract it. So there's a simple example again with the 5 elements where a main menu is specified with 5 items in it. And we basically abstract it to just say what is the menu and what are the items within it. And SAM also supports hierarchical menus. So if you have a nested structure, you could also just integrate that in the description. And the next important component is the user logging, of course, so how you record the user data. So each time a user performs events on a web page or on a web page menu, SAM records each of them. Things like mouse clicks, page visit durations, or cursor movements, all these can be recorded by SAM. And you could insert your own data as well here, what other aspects you want to integrate into the logging. For example, you might want to add eye tracking data to your user logging, and you could do that with SAM as well. And in the next stage, we use this user logging and the abstraction of the menu to finally implement the target policy, which computes scores for each element. And in SAM, we've already implemented a few different target policies from literature, such as click frequency, which is basically the number of clicks on a menu item. Okay. Sorry about that again. Yeah. Or page visit frequency, which is how many times you visited a different page specified by a link. Different aspects such as page visit duration, and we also have more sophisticated policies such as the serial position curve, which combines the frequency, the recency, and how the primacy of different visits, or access rank, which is a well-known policy from literature, which also combines different aspects such as temporal clustering or the time of visit. And finally, you could also include your own policy to extend SAM. Next in the pipeline, once we have the scores for each menu item, we can apply an adaptation style. And again, we've implemented several different adaptation styles that you can already readily choose from. Things like highlighting, where you have different elements that can have different saliencies, or reordering of items, where you reposition items to make them more prominent. And you can also reorder groups in case of hierarchical menus. Or you could implement something like folding, which is actually already implemented. So folding is basically, if you have, for example, a long menu with 10 elements, you might want to fold it to just show 3 and then an additional button saying show more so that you only show the most prominent ones, thus reducing visual clutter. And again, you could implement your own style as well and easily integrate that into SAM. And finally, you could also combine multiple styles to form composite ones. For example, it might be beneficial to combine highlighting with reordering to show you where elements have moved and which elements have moved. And finally, once we've applied adaptation style by modifying the DOM elements themselves, you have a fully adaptable menu on the right-hand side. And this is basically our SAM framework. It contains these 4 modular components, and it's built on JavaScript and CSS. And it's entirely client-side, so it basically preserves the privacy of the users. None of the logging data is sent to the servers. And you can basically access everything offline. So how do I, or you as a user, extend it? We've answered that in 3 different ways. So you could be an end user who's just trying to adapt to websites that you visit. You could be a practitioner who's developing websites, or a researcher who's doing more research on menu design and menu adaptation. First, for end users, what we do is we give you a platform with which you can make website menus self-adapting by just injecting the SAM code. So to do that, you basically specify selectors for different menus on a web page that you visit and inject the SAM code onto it. This can be a bit challenging for novice users, of course, because you need to specify the selectors by inspecting the HTML and things like that, and not everyone can do that. But you could kind of have a crowdsourced repository of different menu tags, which basically would then facilitate adoption by end users. There are more details about how this can be done in the paper. Next, as a practitioner, so if you're developing a website and you see that you have several menus or one complicated menu on a website which you wish to make adaptive for the user, you could also easily do that as a practitioner. You would basically define which menu you want to adapt, specify the elements of that, and just add the SAM code to the back end. And with that, you could quite quickly and easily make your website completely self-adapting. And finally, as a researcher, what many of us do is basically we try to create new types of policies, new styles, and new interaction techniques for making menus adaptive. So SAM provides a framework where researchers can experiment and add new policies. So we've already implemented a set of 5 to 6 policies, but you could easily extend them by trying to figure out what kind of data you want to use for logging and how you would process this data to compute scores for each element. Or you could experiment and add new adaptation styles. For example, we heard about the split menu earlier as well, where you basically replicate some of the important elements in the top part or a different part of the interface And you could also then implement that as a new adaptation style or add magnifying, for example. So you could do all this kind of experimentations and easily integrate this into the framework. And then finally, by doing that, you could also then conduct studies in the wild with real websites. So you wouldn't be stuck with toy examples, but you would actually be using real websites with users. So all this can be achieved with SAM by just adding simple adaptations and extensions to the code. So let's move on and see how this actually works. I'll try to do a live demo if I have internet. Okay. So yeah, this is my Firefox browser, and I've integrated SAM on a couple of websites here. I'll start with the Wikipedia page, let's say. And you can see there's a SAM debugging toolbox on the top right corner. I'm not sure if you can really see them, but there's a drop-down menu for the selection of styles and policies. So I can start with different policies. For example, just most clicked items, which is item click frequency. And I could select a style saying I want to highlight elements that I click often. And basically, I've already specified the Wikipedia menu in my SAM configuration, and I can start using them. So if I click on main page, it's been highlighted now, since that's the only item I've clicked so far. And basically, SAM would then continue recording my clicks, and it would be across the entire website domain. So you can see that as I click on different items, it's going to continue computing the scores. But in this case, maybe the policy might be quite naive and I want to use something else, for example, the serial position curve. So as soon as I switch the policy, a different set of items has been highlighted. Maybe instead of highlighting, I want to try something else. I want to maybe try out a different style where I do something like both highlight and reorder elements. So now you can see the highlighted elements have also been positioned to the top. Or I might want to do something like fold the menu. So now you see just the prominent items have been displayed and the others are below on a show more page. And all this is done completely on the client side. All the data that I've been logging, things like user click and page visit duration, is just stored on my computer, on my browser. I can go onto a different web page, for example, Craigslist, which has this grid-like menu, which is quite complicated. So if I look at it now, finding things that I visit often might be quite hard. So I'm going to try to improve that. I'll take a policy. Again, I'll pick serial position curve, and maybe I'll just use highlighting. So now every time of course, when I click on something, it's going to go to a different page. But then when I return to the main Craigslist page, it's going to continue adapting it. So you can see that as I use different items, nice. Let's look at some pets. Yeah. And I could, again, adapt it using different styles, so I could reorder them now or fold. So that's a basic demo of SAM. Let's go back. So in this way, SAM provides you with a JavaScript and CSS-based framework, which you can download and start using immediately. We've open sourced it and published it on GitHub as well. And I'll be showing a demo of this later today as well. So please come and try it out. And if you want to discuss any of the different aspects, I can go into detail into each one of them later. Thanks. I'll be happy to take some questions.
Great talk. So we have a little bit of time for questions. Peter?
Hello. Hello.
Hi.
Hello. Thanks. It's interesting. It looks like you kind of implemented old classic models, and which has been explored for the last 30 years in the areas of adaptive menus and adaptive hypermedia. But what we know, quite a number of these adaptations are actually harmful. And you kind of opening a can of worms, making harmful things very easy to do without actually guiding the user which things are harmful, which are not. In fact, if you collect this data, you can decide very easily for the user whether the adaptation in the case is harmful or not. There are quite a lot of guidance provided in the past.
Yeah.
So have you thought about that? Because so far, it's like very nice set of tinkering for the homemade bomb maker, right?
Yeah.
Push and boom, right?
Yeah. Yeah, I have in fact thought a lot about that. I think this morning I also had a question about that because, of course, like you're addressing the issue of the cost of adaptation that might occur because of the different adaptation techniques or different styles of adaptation. For example, if you move around elements, it might be quite expensive to the user. We are still working on that, so that's one of the future things we want to improve upon is like come up with new policies that try to minimize basically this cost of adaptation and also how this can be addressed with new adaptation styles. Because you could, for example, highlight changes to the user to make it more evident that things have moved. But we haven't really found the winning recipe so far for that. But indeed, this opens up a toolbox. So as I said, end users can, of course, apply this, but we're not sure if every time the changes will be positive. This needs to be, of course, like then evaluated in the future. I think if a practitioner is implementing this in their website, they might have some better idea of what kind of changes might be more useful. So they might decide that only highlighting should be available to the user and enable just that in their toolkit when they do it. Thanks.
Time for just one or two more questions. Peter asked the question I was going to ask. The same thing on my
But yeah, please come and try it out later if you want, and if you want to try adapting it on your own website, then you can just download or clone the repository and tinker around with it. Hopefully not break your websites.